Hello, everyone. My name is Ike Anyam with Holt Integrated Circuits, and today I'm excited to introduce our HI-84216. This video will focus on the device's internal PWM clock generator. The Holt HI-84216 is a programmable 16-channel low-side driver featuring SPI control and integrated load current sensing. Designed for robust performance in demanding environments, it offers precise control and comprehensive diagnostics for a wide range of applications. The main feature we'll be showcasing today is the internal PWM clock generator, which has 16-bit resolution for precise control. But I also want to highlight some other core capabilities and features. The 84216 has a 40 MHz SPI host interface for seamless communication, an internal 8-bit ADC for accurate channel current and temperature measurements, a wide variety of protection features like overcurrent protection and open and short load detection for robust operation, and lastly, wide 1.8 volt to 5 volt digital I/O supply compatibility. The 84216 is designed for robust power and is ideal for precision control for diverse needs. It's capable of syncing 250 milliamps per channel, and you can use all 16 channels in parallel for a combined total current sync of 4 amps. It has an on resistance of 500 milliamps per channel, which enables it to achieve ultra-low leakage current of less than 1 microamp. It comes in industrial and extended temperature ranges, as well as burn-in options to reduce infant mortality. The HI-84216's high-power channel driving, flexible control, and efficient design are all advantages that make it the ideal solution for your design. It also boasts high reliability. With its integrated diagnostics, the HI-84216 continuously monitors output current and die temperature to support system health monitoring and fault management. This device is ubiquitous and can be used in many different applications. From aerospace and defense, LED and lamp control, motor and valve control, industrial automation, relay and solenoid, and many more. Now, where the 84216 really stands out is its programmable precision without any external hardware, specifically the internal PWM clock generator. This device allows you to generate PWM waveforms from 24 Hz to 48 kHz with 16-bit timing resolution. This enables repeatable and accurate control of avionics loads such as annunciator lamps, LED indicators, relays, and solenoids. Now, let's go through an example of generating a PWM waveform with the 84216. Let's say we want to generate a 250 Hz waveform with an ultra-low duty cycle ratio of 1 to 3000. We'll do this manually first, and then I'll show a tool that will do the calculation in seconds. The configuration is a 4-step process. First, we calculate the internal clock period. Then, we calculate the target PWM period. Then, we calculate the PWM pulse width and recalculate the PWM period. And lastly, we determine the error margin and program the applicable registers. First, establish the internal clock period. This step is pretty straightforward. The 84216 utilizes a fixed 50 MHz internal clock, so the period is simply 1 over 50 MHz, or 20 nanoseconds. Next, we calculate the PWM period using the equation shown here. This part is a little tricky though, as the PWM period is limited by the 16-bit resolution, so it can only be between 1 and 65,536. Additionally, the prescaler is a variable range from 1 to 32. So we have to take an iterative approach here. Let's start with the prescaler value of 1. With the prescaler of 1, we run into an issue. This gives us a PWM period of 200,000 cycles, But as mentioned, the PWM period must be less than 65,536. So we need to go back, try a different prescaler, and do the calculation again. When we try a prescaler of 6, we get a PWM period of 33,333.33, which is a valid PWM period less than 65,536. Now we move to the next step of calculating the PWM pulse width. Using the equation shown, we calculate 11.1111111. This needs to be an integer though, so we simply round to the nearest whole number, which is 11. The PWM period also has to be an integer, so we readjust the equation and calculate the PWM period using the pulse width result of 11 we just calculated, and we get 33,000. In the final step, we calculate the frequency error. Since we did some rounding and recalculating for the PWM pulse width and period, the resulting PWM frequency will not be exactly as we originally intended. The actual PWM frequency we will generate is 252.53 Hertz, which has an error of around 1% from our target frequency of 250 Hertz. If this error margin is acceptable, then we can go ahead and program the applicable registers. If the error is not acceptable, then we must go back and do the calculations all over again with a different prescaler to see if we can get a smaller error. There are 32 possible prescaler values though, so this can take quite a bit of time. Instead of doing the calculations by hand, you can use the PWM calculation tool to do the grunt work for you. This tool will automatically cycle through all possible prescaler values and pick the one that has the lowest possible frequency error. It will then generate the exact register values for you to program, saving you precious engineering time. Now, let's see the tool in action. When you open the executable, this will be the first window you see. You simply click the button to begin, and you follow the prompts. First, we enter the duty cycle ratio using 3000 as an example, 1 to 3000. Then the PWM frequency. Let's use the same 250 Hertz that we used for this example. And this window is telling you that you can click yes to see how the calculations were done if you want to go through all the math, or you simply click no. And the tool outputs all of the different values that we need to program the registers, as well as the registers that you need to write with the applicable values. The 84216 eliminates the need for external timing hardware with its internal PWM generator. And with our PWM calculation tool, you can easily generate the lowest error PWM waveform without the need for any manual calculations. For more information, please visit holtic.com, where you can find the datasheet, application notes, application development kits, the PWM calculation tool, and many other resources and support for your design. Thanks for watching.